Hey everyone. I'm doing a voiceover today because I've realized putting text on the screen is a lot more work than I had anticipated. Anyway, it has been a while since my last update. I've been a bit busy, but I did find some time to work on a new hardware revision for this device, which I still haven't come up with a good name for. I'll point out a few of the more noteworthy features of this new design, and you'll see the rest during the software demo. One of the first things you'll probably notice is the bigger screen. This is a 128 by 128 color OLED display. This is a pretty big upgrade to the graphics I can show on here, and the general navigation of the device software. All the keys on the device have been upgraded to these Gatoron low-profile mechanical switches. Now, I really like the feel of these switches. They have a pretty short travel distance and a low actuation force, which I think is perfect for this particular application. On the bottom left, you can see a 2-axis PSP-style thumbstick, which can be used for any type of analog input to the device. This is flanked on either side by some NeoPixel LEDs, which can be used for navigation, display, indication, or whatever else. The volume knob now has a handy little LED display that shows the volume level. The LEDs are a little bright at the moment, but that is a pretty easy thing to fix. On the back, you can see the enclosure is printed in 3 separate pieces. Underneath the middle one, you can see the LiPo battery peeking out from the right-hand side. And right here, you can see I've included a little FM radio module with a board antenna. I haven't gotten around to testing this out quite yet, but I am looking forward to having fun with this. Now, aside from this, there is a new better power supply in the device, and I've also gone ahead and built the Teensy audio board right into the device. You can see here the headphone-out port and the audio in port. Big thanks to PJRC for making the schematics and everything for the audio shield available on their website. There's also a good bit of extra PSRAM and serial flash memory that I'll hopefully be able to use for better sampling, recording, and playback functionality. There are a few minor hardware problems with this particular board, which I don't really need to get into right now, but I am hoping to fix all these problems with the version 2.1 PCB that I'll push sometime in the next week or so. I've tried to make the hardware as cheap as I can. The total cost of materials and parts for this particular version of the board comes out to $125 US. This, of course, doesn't include the 3D printed parts and the time it takes to build. It does use mostly SMD components, so it can be a little challenging to put together, but I managed to do this one in just a few hours with a regular soldering iron, so it is manageable. I'll try to publish a build time-lapse sometime soon. Anyways, let me know what you guys think of the look and the layout of the device, and with that, let's jump right into the synth demo. So what I have today is a Subtractive synthesizer engine. Now, I've already done something like this with the previous version of the device, and you can find that video on my channel, but what I'm showing here today is basically a port of that software with a few new enhancements. More than anything, this is really just a way for me to experiment with designing the UI and navigation around a color display, and it let me establish what's essentially a software framework for this new device that I can use to build other synthesizers, samplers, or whatever else. Before we continue, let me just go ahead and throw up my magic floating screen so you can get a better look at what's going on. Alakazam, and we're ready to go. So starting off, we have the oscillator screen where we can select between a number of wave shapes for each VCO. And set the amplitude level. Notice the LEDs under the encoders here. I added these so I could easily show what controls are active at any given time. The color of the LED matches the parameter on the screen that the corresponding encoder will be controlling. As another example, if we select arbitrary waveform option on either of the 2 VCOs, you can see that the blue encoder LED lights up. Pressing this brings us to the waveform editor screen, turns off the lights under the other encoders, and lights up the LEDs around the joystick, indicating that it's now in active control. Now we can use the arrow keys and the joystick to go through and draw our own 256-point waveform. Pressing the blue encoder again brings us back to the main menu. So different synth settings are spread out across a number of screens, as indicated by these little yellow arrows on the top of the screen. Turning the yellow encoder lets us scroll through them. Here's the envelope screen. And here is the oscillator tuning screen, which lets us select how many semitones up or down to shift the frequency of oscillator 2, or how much to detune it. For oscillator 1, we can transpose it up or down 2 octaves using the arrow keys. And that's shown on the top left corner of the screen here. Next up is the low-pass filter with resonance. Now this is a fun one. Since we do have analog control inputs in this version, we can use them for different kinds of modulation. Currently, the only options I have for the joysticks are pitch bend and filter modulation. But these can be mapped to either of the 2 axes on the joystick, or disabled completely. You can also see that both axes are not allowed to control the same thing at the same time. The axis that was assigned first always takes precedence, and the other option is grayed out. Moving on. Last but certainly not least is the mod matrix, which is one of the cooler features I was able to stuff in here. I got clued into the idea of a modulation matrix by a commenter on one of my other videos, who advised me to check out the mod matrix from the Arturia Microfreak. I really liked the flexibility that this kind of modulation provided, so I decided to try and implement something similar in my own device. Now, obviously what you see here is not a matrix visually, but that's mainly because I couldn't figure out how to make a matrix graphic look good on this tiny little screen. Regardless, at the moment we have 4 independent modulation sources, 2 LFOs, and 2 envelopes. Clicking on one of the LFOs gives us 2 options, to edit the modulator or to assign it. Let's assign this one to oscillators 1 and 2. Now we can go back and edit the LFO to hear what effect it has on the sound. Just like with the main oscillators, we can select an amplitude, a frequency, and a wave shape. We can also go back and try putting the second LFO to a different mod destination, like, for example, the filter. Once again, we can set the amplitude and the frequency. And the wave shape. Or the LFOs can also be assigned to each other. Let's try assigning the second LFO to the first LFO. Now, going back and selecting envelope, we can see we're given the same assign and edit choices, but with a different set of options inside each. Let's assign this envelope to LFO1. Now, as soon as we do this, You can probably hear that the LFO's direct connections are severed, and instead it's routed only through the envelope. This means anywhere we assign the envelope will also receive the modified LFO signal. Let's assign it back to oscillators 1 and 2. If we go to edit, we can adjust the various parameters and hear the effect it has on the sound. We can also add a DC offset here to shift where the envelope ends up. Well, that's pretty much all I have for today. There's still a lot of functionality I'm hoping to put in here, and I'm sort of just figuring it out as I go. So I really appreciate everyone watching these videos and leaving helpful comments. As usual, you'll find more details about the build and all the hardware and software files in the description. Hope you have a nice day, and I'll see you in the next one.